Welcome to Lecture Online, and here's our next example of how to simplify a rational expression. This is quite a complicated one. We have a numerator that has a fraction in it, and we have a denominator that has two fractions in it. Notice all the denominators of each fraction. We have an x minus 2, an x plus 2, and an x minus 2. The smallest common factor of all the denominators is the product x minus 2 times x plus 2. So what we're going to do is we're going to multiply the numerator and the denominator by the smallest common factor of all the denominators. That makes it a lot simpler of an expression. So what we're going to do here is multiply the numerator by x minus 2 times x plus 2. And of course, we have to do exactly the same to the denominator, x minus 2 times x plus 2. When we do that, we get rid of all the denominators. That's the way to eliminate those. So we multiply this times the first fraction. Notice the x minus 2 cancels out, and we're left with x plus 1 times x plus 2. This is equal to x plus 1 times x plus 2. Notice here we don't have anything in the denominator, so this simply becomes 3 times this product. So plus 3 times x minus 2 times x plus 2. There's nothing to eliminate here. In the denominator, notice when we multiply this fraction times this, the x plus 2 cancels out and I'm left with the x minus 2. So the denominator becomes x minus 2 times what's remaining, which is in this case the x minus 2. Minus 1 time, now here we have x minus 2 cancel out x minus 2, we're left with the x plus 2, so it's 1 times x plus 2. Now to simplify this further, we should multiply everything out and combine like terms. So this becomes, we multiply this together, x squared plus 1x and 2x together is plus 3x plus 1 times 2, which is 2. So when I multiply those two binomials together, I get this. Plus 3 times, we'll do it in 2 steps, multiply these together. Notice when this is a minus and this is a plus, you'll end up with an x squared minus 4. The difference of squares when factored gives you this. We divide that by, over here when we multiply this together, we get x squared minus 4x plus 4 minus this times this, which is minus an x minus 2. The negative applies to both the x and the minus 2. Now we still have to combine these together. We multiply this out, see what we get. So this is x squared minus, not minus, but plus 3x, plus 2, plus 3x squared, and minus 12. The whole thing divided by, let's see here. Here we can already combine like terms in the denominator. We have an x squared. We have a minus 4x and a minus x. That gives us a minus 5x. And a plus 4 minus 2 gives you a plus 2. So that's the denominator. Now let's also combine like terms in the numerator and see what we get. So first of all, we have an x squared and a 3x squared, which gives us 4x squared. We have a 3x. That's the only term with an x in it, so plus 3x. And then finally, plus 2 minus 12 gives you a minus 10. So when we divide that by the other denominator, 5x, here we have x plus 2. And then the only thing we potentially could do, if possible, is factor that out. But I don't believe we can factor the denominator, and it doesn't look good for the numerator either. Let's see here. The numerator might be able to get factored, but I don't believe so. Anyway, what we wanted to do is write this into a single expression like that, simplified as much as possible. And so, again, that's how we do that. The trick, look at all the denominators, find the smallest common factor, multiply both the numerator and the denominator by that smallest common factor, and then you simplify. And that's how it's done.